Hi all, welcome back to my lecture series. This is Muthuminal R, Assistant Professor from the Department of Agricultural Engineering at SNS College of Technology. Today we'll see the topic on crop health monitoring and precision agriculture that comes under the unit application of RS and GIS in RS and GIS under the subject Geographical Information System for the students of third year, fifth semester. Before going into the session, let us have a small recap what we have seen at the previous class. We have seen something about spatial analysis where the data that have been extracted by us could be analyzed in the form of converting the raster data and vector data. The second one that we have seen is crop acreage estimation and how we can predict the crops condition under certain soil parameters and how we can map the soil erosion. And at the previous lecture series, we have seen how we can identify water resources inventory. Today we'll see about the precision agriculture and crop health monitoring that could be done with the help of GIS and GPS, and then how the data could be predicted. So here, as you all know that precision agriculture usually benefits from the emergence and convergence of several technologies including the global positioning system, geographical information system, and the remote sensing. These kinds of site-specific management and accurate monitoring is commonly done with the help of mapping the problem areas, recurring monitoring, rapid infestation response, and geospatial analysis and visualization. So the main challenges that we face through is the rising input cost, climate variability, and pest pressure. So in order to identify the input cost, we have to collect the data which is related to that of fertilizers, pesticides, and water resources that are becoming increasingly expensive and squeezing profit margins. Emerging pest outbreaks and diseases also needs a rapid and targeted response. Unpredictable weather and pattern, droughts and everything plays a major role in the crop monitoring. So why we need precision agriculture? Because certain data or the certain development of crop requires a targeted input application. That means that precision farming technology will ensure the application such as spraying, the nutrient replacement based on the local circumstances of a given field. So we are going to primarily concentrate on every individual crop and every individual location so that the outcome will be in a very good output. So this could be achieved with the help of variable rate treatment where the data gathered using GPS and GIS can be accurately communicated to a field manager who may then employ an operator to apply the correct chemicals only where they are needed. This includes the site-specific applications of fertilizers, which remain the leading application of PA today, that is precision agriculture today. So the diverse type of precision agriculture technologies have been experimented with worldwide, often occurring an variable rate treatment application of fertilizers and herbicides. So this will also help us to monitor the yield monitoring and diagnosis where the crop health monitoring comes into existence. The crop health monitoring usually deals with three stages, that is GIS integration, remote sensing, and targeted action. The GIS integration helps us to combine the spatial data layers including soil composition, weather patterns, topography, and historical crop performance maps. Remote sensing will help us to collect the data with respect to that of multispectral imagery. The targeted action enables the precise intervention for irrigation scheduling. So let us summarize what we have seen today. Ultimately, the motivation for the widespread adoption of precision agriculture technologies like GIS and GPS are driven by the potential for economic gain from related agricultural inputs, improved farm management efficiency, and public or legislative concerns over the excessive use of agrochemicals. So that means that whenever we are dependent upon a crop's health, it is really mandatory for us to identify the systematic approach and the driving force for adoption, which will lead us to measure the success and the near future. So PA plays a major role with respect to that of crop health monitoring, and also we have seen the involvement of GPS, GIS and integrated system benefit by comparing them with the variable rate treatment technologies, and also I have quoted about challenges and adoption. So here I have shown you a mind map which we have seen for today's session and I have summarized here. So this is what I have prepared for today's class, and for today's session we'll see an assessment quiz. The question is, according to the provided review, what is the fundamental concept of precision agriculture? So the options are application of synthesized fertilizers, genetic engineering, focusing on replacing traditional farming, agricultural approach that addresses the main feasibility, that is field variability. So this is going to be the answer, because we are going to locally identify each and every position and utilize the data for which we can provide a agricultural approach in detailed manner. So these are the references that we have seen today, and this is what I have prepared for today's class. If you guys have any kind of doubt or anything, you guys can ping me anytime. See you at the next class. Thank you.